Hey everybody, welcome back. Today we want to continue the topic we left off with last time, continuing to factor some of the quote-unquote special cases. Whenever you're factoring a polynomial, instead of having to go through the entire process of guessing and checking, sometimes if you realize what type of question you have, you can do a shortcut and get the answer a lot quicker than you would with the regular method. So just as a quick review, the last video I made, we talked about the difference of two squares where it was always a subtracting question, and it might have looked something like, just making this up, something like this, right? 25y to the second minus 81w to the fourth. You can see both of my coefficients, right? Both of my numbers are perfect squares, and both of my exponents on the y and the w, they're both even numbers, and it is a subtracting question. So this is a difference of two perfect squares, right? Squares meaning numbers that you can do the square root of, and it works out to be a regular whole number without a decimal on it. And so the shortcut the other day was to say, okay, what's the square root of 25? That was 5. If I took y squared and cut it in half, it's just going to be y to the first and y to the first. And then the same thing with the second parentheses for the 81. The square root of 81 is 9. And then the w to the fourth, you have to kind of divide it up. Whoops, didn't give myself enough room here. You got to do half of the 4, so it's 2 in this one and 2 of it in this one. You always have to cut the exponent in half. And then it was called a difference because one was a plus, one was a minus. That's why we only have 2 terms. We don't have all 3. There is no trinomial. That's what we did the other day. And it wasn't too bad. All you had to do is the square root of the first term, the square root of the second term, make sure one parentheses had a plus sign, one parentheses had a minus sign, and you're golden. It was 100% right. Now today, you can look at my title and see that now we're going to be doing trinomials, right? Trinomials have 3 terms, so this question is not an example of what I'm talking about. Right? You know how the other day, oh man, I bet it's been a couple weeks ago, we would get questions like this. We did this right before we left for a break. We would get a question like this, and sometimes they would just put squared. Sometimes they would actually put the same parentheses 2 times in a row. Usually they just put the squared sign though, because that's how most textbooks will write it. And if you're going to do FOIL, or if you're going to distribute, if you're going to do all that jazz, you would eventually realize, hey, these kind of have a special pattern because it's the same exact parentheses 2 times in a row. The answer is kind of unique. And so what made this answer unique, if you did this times this, 3w times 3w, if you did 3w times 5, here's what made it unique. Now if I have to distribute the 5 times 3w, see how these 2 in the middle that I've just written right here, these 2 are the exact same? That happens every single time. And then 5 times 5 is 25. So anytime your 2 parentheses are identical, these 2 terms in the middle are also going to be identical, right? And that's what made this one kind of special. And so if you got the hang of these when we first learned it, or if you watched my video and you're starting to remember, oh yeah, I remember seeing something like that, there was always a shortcut to do these. And the shortcut was, instead of having to distribute and draw those arrows like I did, you can just do this squared, right? 3w times 3w. That's where the 9w squared came from. You can do the 5 squared, 5 times 5. That's where the 25 came from. And then to get the term in the middle, you'd always do this times this, and then you would double it. So 3w times 5 is 15w, and then you double it, because it's the same thing twice in a row, and that's how you came up with that. Now, that's not actually what today's lesson is. That was earlier in the chapter. That was how we multiplied special cases. What we're going to be doing today is we're going to be doing the actual opposite of what I just demonstrated, right? We're going to get this as our question, and we need to come up with the 2 parentheses that led to this as the answer, right? So let me rewrite this down here. So today, your question may look like this. I'm just going to copy down that answer. So we're basically doing the complete backwards routine from what we did earlier in this chapter, right? This is going to be your question, and they're going to ask you, okay, factor this. Uh-oh, right? Kind of tough. It's really not as bad as it looks. In fact, I think I made it look a lot more complicated up there than it really is. First thing you want to look for, is there a greatest common factor? Can I divide all these by a certain number? I mean, these two I can divide by 3, but does 3 go into 25? No, it doesn't. So there's nothing in common. And so now what I want to look for is this a special situation, right? Do I know the square root of that? Is that a perfect square? Yeah, it is, right? We know the square root of 9. Is this a perfect square? 25. Yeah, it is. This term in the middle is usually not a perfect square, and you know what? That is okay. This does not have to be a perfect square. But this one right here and this one right here, your first and your last in your FOIL, right? F-O-I-L. The F and the L have to be perfect squares. And if they are, you can do this in your head in about 10 seconds, right? Do I know the square root, right? Remember square root. Do I know the square root of 9w squared? Right? What's the square root of 9? Well, that's 3w and 3w. Do I know the square root of 25? Right? That's 5 and 5. And then how do I know whether to put a plus sign or a minus sign in my parentheses? Because it will be the exact same in both parentheses. The other day in our lesson, we had one with a plus and one with a minus. Not so today. Today is completely different. Today, it has to be the exact same. You look right here in the middle, right? This middle will always tell you if this is a plus, you're going to put a plus in both of them. If this would have been a minus, we would have put a minus in both of them. So there you go. The parentheses are identical twins, right? If you don't want to write it like that, if you would rather write it like this, 3w plus 5, only do one parentheses and then put the squared. That's honestly how most textbooks would write it. It just kind of saves time and it saves space. So you can see how easy this is once you recognize the pattern. If the first term is a perfect square, if the last term is a perfect square, you can just do the square root of each one and then just look in the middle to find if it's a plus sign or a minus sign. That's really it. Okay, that's a lot of explaining. I'm already 7 minutes in. Let me go to some examples here. Oh, my title kind of got smeared away there when I carried it down here. It's okay. Okay, number 1, let's go through these pretty quickly because, like I said, you can do these in about 10 seconds each. Okay, is there anything that goes into all three terms? A greatest common factor? I could divide that by 4. I could divide that by 4. Cannot divide that by 4. There's nothing in common. Okay, so now I'm looking. Are these perfect squares? Is this a perfect square? Yeah, it is. Is this a perfect square? Of course it is, right? Notice how all of these always have a plus sign right in front of this last term, your C term. It has to be a plus sign right here. If this was a minus sign in front of any of these numbers right at the end, it would not work. But it's a plus sign, so we can do it, right? Do I know the square root of 16x squared? Yeah, I do. The square root of 16 is 4x. Do I know the square root of 25? The square root of 25 is 5 times 5 equals 25, right? Now, how do I know whether to make it a plus or a minus? I look right here in the middle. These had to add up to positive 40, and the only way they can add up to positive 40 is for there to be a plus sign right there. Now, do you see how fast that was? Do you remember how we had to do these the other day? The other day, we just had to guess. Remember having to make that list? Like, okay, guys, guess and check. What are all the ways they could get 16? And we could do 16 times 1. We could do 2 times 8. We could do 4 times 4. All right, and then how are all the ways to get 25? They could have done 25 times 1. They could have done 5 times 5, right? And we had to just guess and check and see which one added up to 40. And that took, what, 5 minutes, 10 minutes maybe? It took a long time. And so when they're both perfect squares, right? You know the square root of them in your head. You see how much faster this is? This is so much more efficient as far as our time goes. Here's another one. Okay, is this a perfect square? Yes. Is this a perfect square? Yes. Do I know the square root of 4? I hope so, right? I know the square root of 4x squared. The square root of 4x squared would be 2x times 2x, right? That would be 4x squared. And so that means the first term in my parentheses is 2x. Do I know the square root of 49? That's 7, isn't it? 7. And then I look in the middle. These had to add up to equal positive 28. So that means there's a plus sign in there. And then the whole thing is times itself because it's just the same parentheses multiplied by itself. Okay. Now, number 3. Same type of question. Hopefully we're starting to get the hang of these. All I'm looking here is at the first term and the last term. For the letter F, they got 25x squared. Is that a perfect square? Do I know the square root of 25x squared? Yeah, I do, right? That's 5x times 5x. It's not going to be 25 times 1. It's got to be 5 times 5. Do I know the square root right here with the letter L of 9? Do we all know the square root of 9? I hope so, right? That's 3 times 3. It's not going to be 9 times 1. It's got to be 3 times 3. Now, how do I know if it's a plus sign or a minus? I look right here in the middle where the O and the I in FOIL are. You can see how this is minus or negative 30. So that means I should have a minus sign right there between my two terms. Simple. Okay, let's do one last one on this board. Scoot my phone down a little bit so I have space. There we go. Number 4, we have another perfect square right here. Do I know the square root of 25x squared? Sure I do. That's 5x times 5x. Right? It's not going to be 25 times 1. It's got to be 5 times 5. Since this is a perfect square, the number 4, I know what that is. That's 2 times 2, right? I can go with that. And then I look in the middle. In the middle right here, this has to be negative 20 or minus 20. So that's a clue that I have a minus sign right there. Boom. I put my squared on there to save a little space. Look at that. I didn't have to guess on any of these. I didn't have to check on any of these. I didn't have to make a list of all my different combinations. I can do all those in my head. Very, very efficient. Okay, let's try the next board. I try to make these a little more complicated. They're not that much more complicated, but I could see these sometimes causing people some confusion as they looked at them in an assignment or on the computer in the book or something. 25 or number 5 is so easy that I feel like it could be hard for some people. This is actually a throwback to way back at the beginning of the chapter, right? Since this is just a regular x squared, I could technically do this in my head with the little mental math trick, right? Do I know two numbers that would multiply together to equal 25 that would add up to equal 10? Right? You could do it with that exact same thought process that we had earlier in the chapter. But this is also a perfect square, isn't it? Because technically this is a 1. Do I know the square root of 1? Sure I do. That's 1. So it's just going to be x times x. Do I know the square root of 25? Yeah, that's 5 times 5. And then I check the middle. The middle term is positive, so that means this is going to be positive. If I really wanted to put another parentheses that says x plus 5, I could put it right here. But I'm a fan of just putting the squared sign because that's so much faster. And it saves time and it saves space. Okay, our book, and I don't know how your teacher and your assignments will have it, but the book that we use is going to also try to throw some curveballs in there by giving you some fractions. Don't let the fractions throw you off, right? This is still something that we can handle, right? This is still a coefficient of 1, so that means it's going to be x times x. This, even though it's a fraction, sometimes they'll give you fractions, but usually when they do that, the fractions that they give you, both the numerator and the denominator, are perfect squares. So we know this in our head. Don't get fooled by this and think, oh, there's a fraction. I don't know how to do it anymore. No, yeah, you do. Do we know the square root of 4? Yeah, that's 2. Do we know the square root of 25? Yeah, that's 5. Right? And then I check in the middle. This is a plus, a term that has a positive on it, so I'm going to have a positive right there. Right, so don't let them mess you up by putting a fraction, right? If they did something like this, 49 over 81, and you can just do the square root of both of those in your head, right? The square root of 49, square root of 81. Right? If they gave you if they gave you, I don't know, 16 over 169, right? We could still do that. Do you know the square root of 16? Yes. Do we know the square root of 169? Yeah. So if they give you fractions, don't have a freak out moment. You still know how to do it. Just do the square root of the numerator, do the square root of the denominator separately, and then those are your two parts of your answer. Okay, number 7 and 8. Here's where I tried to get extremely tricky. This is about as hard as they can make it. They'll try to disguise these so it doesn't look like they're actually perfect squares, right? When you're looking at this, you're like, whoa, wait a second. I don't know the square root of 18. That's not a perfect square. And I don't know the square root of 32. That's not a perfect square. So does this mean I have to guess and check and do all that stuff all over again like we did a couple, lessons ago? Not necessarily, right? Before you just automatically go to the guess and check method, look at your 3 terms. Is there a greatest common factor? Do they all have something in common? I think they do, right? Can we divide all these numbers by 2? Right? They're all even. So could I factor out a 2? If I divide all my coefficients and all my numbers by 2, what do I have left? Instead of 18, 18 divided by 2 is 9. Instead of 48, 48 divided by 2 is 24. Instead of 32, 32 divided by 2 is 16. And now look what we have. Right? Is this a perfect square trinomial? is your letter F and is your letter L, are those perfect squares? Of course they are. Here's your O and your I combined together. They're not going to be perfect squares, and that's okay. As long as this and this is perfect squares, we can do this one with a shortcut, right? Keep that 2 out there. Don't forget it, because I love to forget that. Do I know the square root of 9x squared, right? What's the square root of 9x squared? That's 3x. Do I know the square root of 16? I hope so, right? That's 4. And then check in the middle. The only thing the O and the I is really here for is to tell you whether it's a plus sign or a minus sign, and that's a plus. And so this is going to be a plus. And look at that. We didn't have to guess. We didn't have to check. We didn't have to spend 20 minutes making all the combinations and working them out and testing them out to see if it equals the right amount. No. We can do it in our head. We didn't have to do any guessing on that question at all. We had every single ability to knock it out in what? 45 seconds total, right? Here's another one, trying to be tricky. Now, 100 is a perfect square. Oh, actually, this one, I messed up on this one. These are actually both perfect squares. Okay, I apologize about that. So let's just act for a minute like we didn't know these were perfect squares. And you're like, oh man, those are kind of big numbers. Well, you know what? Let me actually do this one the other way. We know these are perfect squares. So we know that the square root of 100x squared is 10x and 10x, right? 10 times 10. We know the square root of 144 is 12. But then we have a problem here, right? This has to be a subtracting sign. And so this is our answer, but hold up. Can I really circle that and say that I'm done? Not really. Can I? I kind of have a problem. The problem that I have is these still have something in common, right? Is there still a greatest common factor between these terms, right? Can I divide something away from 10 and 12? I can still divide those by 2, right? And so think about what this really is, right? This is 10x minus 12 times 10x minus 12. And that's not really appropriate because you can divide or factor out of 2 on both of those. And so really, if I did this one the right way, we would say, wait a second, you can divide a 2 out of this parentheses. If we divided 2 out of this parentheses, we would have 5x minus 6. And then wait a second, can I also take a 2 out of this parentheses as well? And if I take a 2 out of this parentheses, I'm left with the same thing. And so you can see what we have here. We took a 2 out of the first one. We took a 2 out of the second one. 2 times 2 is 4. We took a 2 and a 2. That's a total of 4. And then my 2 parentheses are both 5x minus 6. And you can just put the squared. Or if you wanted to put the 5x minus 6 2 times, you could. That's probably the recommended way to do that one. You could have divided everything by 4 at the beginning. If you divided everything by 4 right here at the beginning, 240 divided by 4 is 60. 144 divided by 4 is 36. You could have divided 4 out at the very beginning, and then you would have had, okay, the square root of 25 is 5, and the square root of 36 is 6, and it has a minus sign in the middle. Whoops. And so it had to be a minus sign right there. All right, so there's actually 2 ways to get that one. I actually think the way I did it first is a little more complicated. We could have divided everything by 4 at the beginning. Okay, I apologize about that one. We have one last board. And we're almost done. I hope you're getting the hang of these. Now, the only thing that our textbook will do that we haven't covered yet is they'll make some equations because they've been loving these equations all chapter long. If it's an equation where it equals 0 or if it equals something else like this one down here, don't panic. We can still do it. Do it like normal, right? I can't divide anything out of all of these. There's no common factor. So now I'm looking, is this a perfect square? It is, right? I know the square root of that. That is 4x. Do I know the square root of 81? I do. That's 9. And then this has a plus sign in the middle. So I'm going to put a plus right there. I'm going to put the squared. But now it equals 0. And so what I really have to think about is, what is that telling me, right? That's telling me 4x plus 9 times 4x plus 9 equals 0. Remember our zero product property. Anytime you have a multiplying question and the final answer is 0, you know that one of the 2 parentheses that you multiplied together equaled 0. The only way you can get 0 to the final answer of a multiplying question is to have one of the factors, one of the things you're multiplying, equals 0. Now, these are the exact same parentheses. Usually I say, okay, what number would you put right here to make this parentheses equal 0? And what number would you put right there? And usually it's two different numbers, but now it's going to be the same exact number. And so if this is too hard for you to do in your head, what number would I plug in right here to make this parentheses equal 0? Ooh, that's kind of a hard one, right? Just take what the parentheses says, make it equal 0, and then work it out, right? We know how to do this. This is like an easy two-step equation. 4 times something equals 9. 9 divided by 4 is my answer, right? 9 over 4, which is 2 1/4, or 2.25 for you people who love decimals, right? And that's the answer in both parentheses, right? Whoops, negative 9 2/4, negative 2.25. So this answer, even though there's two different parentheses, it's the same exact answer in both ones. It will always work like this. When it's a perfect square trinomial, it will only have one answer. And honestly, what that means is eventually we'll learn how to graph these. And this means that these graphs, they only touch, whoops, I did that wrong. They only touch the x-axis in one place, right? So these are always going to be they're going to touch the x-axis only in one spot, just like this, right? See how there's only one place where it touches the x-axis? The vertex is going to be right on the x-axis. That's why these only have one answer. And other things that may go like this, they touch it in two places. And so these only have one answer because they only touch the x-axis in one place. Eventually we'll learn that. That's next chapter. Okay, I'm getting ahead of myself though. Let's go ahead and knock out these last two, and then that'll bring it into this video. Same thing on number 2. I'm going to do it over here. Do I know the square root of this? 4x squared. I should, right? That's 2x times 2x. Do I know the square root of 9? That's got to be 3. And then I check in the middle right here. This is where my O and my I are. I've already done the F. I've already done the L and FOIL. The O and the I, these add up to negative 12. And so that's a clue that I need to have a minus sign right there. And now I'm asking myself, okay, what number is going to give me this parentheses equaling 0? 2x times 2 times something minus 3 equals 0? That's kind of a hard question. What number would I put right here to make it equal 0? Well, I don't know. So let me just work it out. 2x minus 3 equals 0. What number would I plug in right here to make it equal 0? Well, if I do plus 3 on both sides, I get 2 times something equals 3, and then 3 divided by 2. You could keep it as 3 over 2. Some people say 1.5. Some people say 1.5. There you go. The x-intercept is 1.5, right? So if I was going to graph this, which we don't have to yet, this really means that this graph touches the x-axis. Sorry, I keep saying that wrong. This graph has a vertex right here at 1.5, right? This graph would go something like this. I don't know exactly how steep it is right now off the top of my head, but it would go something like that. It would have an x-intercept at 1.5. Okay, and then we have one last one. Number 3 is rude because it doesn't equal 0. If they give you a question where it doesn't equal 0 at the very beginning, you've got to do one extra step. You've just got to say, all right, you're trying to be annoying. I'm not going to let that bother me. Let me just clear this out. Whatever's over there, let me just move it to the other side. I really don't know where to line it up over here because that equals 0 because it cancels out. But these are all different, right? That's second degree, that's first degree, that's 0 degree. And so I just need to write them in the correct order. Second power, first power, 0 power. Don't let them throw you off. And now I can work it out. This is a perfect square trinomial. Yeah? We know the square root of 9w squared. That is 3w. I know the square root of 100. That's 10. I look right here in the middle. This middle term is positive 60w, so that means that it has to be a plus right here. And now I have an equation. I have it equaling 0. So what number would I plug in to make this equation equal 0? Well, if I can't do it in my head, and most people are not maybe the best at doing that in their head, just take 3w, whoops, you don't want parentheses around it, 3w plus 10 equals 0, and work it out. So ignore that. If I work this out, I get negative 10 on both sides. 3 times something equals negative 10. And divide by 3. I get w equals negative 10 over 3, which is negative 3 1/3, or negative 3.3 at the repeating bar. Since this is squared, that means both parentheses are the same. So I don't really need that second answer, right? This one would have an x-axis, even though it says w. This one would cross the x-axis at negative 3 1/3, right? It would be, if I do -1, -2, -3, -4, it would be something like right there. And this one would go like that. And you're like, wait, do they always go up? Well, these will, but all of them that you graph in your life won't always go up, but all of these go up, at least the ones that we've had in our questions today. So thanks so much for watching, guys. Hopefully that makes sense. If not, you can go back, rewind the videos. You can send me an email if you're having a hard time. For people in my algebra class, I'm going to put some of these questions on our Big Ideas Math website so you can give them a try. And if not, you don't have access to that, I've been shouting out this website, kudasoftware.com, this Algebra 1 site. On the right-hand side, they should have a section for polynomials, and you might see one that says factoring special cases. And what we just went over in today's video will be all of them that are trinomials. So thank you so much for watching, and I will be back tomorrow with a new video.